Hello everyone, I hope you're doing well. So before starting the video, I don't usually say this at the beginning of the video, but I see a lot of people who have been watching these videos have not subscribed yet. So if you find these type of content useful, you can show your appreciation by clicking on the like button and subscribing to the channel. And always you can share with your friends. And it's all free of cost, so why not? And if you don't find the content good, you can always unsubscribe later on. So let us quickly start with today's problem of the day, that is Apple sequences, which is a easy level problem, right? So this particular problem says that we have been given a series of A and O's. So A denotes apples and O denotes oranges, right? And N is the length of the series and M is the number of changes that we can make, right? So for example, I can in one move, for M is equals to 1, I have one move. In one move, I can change this O into an A, right? This is the moves I can perform. I can change any O into an A, or I can change any orange into an apple, right? Now I have to make those moves in such a way such that the length of the sequence of apples or the length of the sequence of A's is the maximum, right? So this is our problem. We have to change the O's into A's in at max M times, right? Such that the length of the sequence of apples is maximum or the length of the sequence of A's is maximum. So for example, if I have been given A, O, A and O and the value of M is 1, my first move should be to change this particular O into an A. So this should be A, and the length of the sequence would be 4, right? And if I had one more move left, if the value of M was initially 2, then I could have changed this particular O as well, and the length of the sequence would have been 5, right? So this is my question. Now since this is an easy level problem, so I believe that there must exist some simpler solution as well, but I did this problem using binary search, and I'm going to share the approach of binary search. And it is very useful, because if you learn binary search, it is very helpful in many other problems as well. So I believe why not share this particular approach only, right? But obviously I think it's an easy level problem, and binary search is kind of overkill for this problem. There might exist simpler solution, which you can always read in the editorial later, right? So let us start with the binary search, how we will do binary search on this particular string. For example, O, A and O, right? Let me just define a range between, so the length of the string is 5, so let me just define a range between 0 and 6. So why I'm taking 0 and 6 only? So the technique of binary search that I use is called invariance technique. In this technique, we assume that one end of the range is always true and one end of the range is always false, right? This can always be possible, and this can never be possible, right, as the answer. So why is this always possible? Like, let us take the worst case scenario when all the characters are O and the value of M is 0. So the length of the longest sequence would be 0, right? So 0 should always be the possible answer in the worst case scenario. Why 6 can never be the answer? I have written 6 here, but it should be actually n plus 1. I have written 6 according to n is equals to 5, right? So why this is never possible? Because the maximum you can get is a series of 5 A's, right? So you can never go more than 5. So 6 is always false, right? So I have decided this particular invariance range, that this part is always true and this part is always false, right? So we have to find the maximum sequence. Now suppose we find some element mid in between, and we have to check whether it is correct for this particular value of mid or not, or whether we can form a sequence of mid number of A's or not, where mid number of A's are together, right? So this the count should be equal to mid. So we have to find such possible sequence. Now how do we check this? So a very simple way is to, like, for example, if I have some O's and A's, right? For example, if mid is 2, right? So the first thing I do is I take the first two elements, right? I take the first two elements and initially store, like, let us call it count of A, right? So I just take the first two elements. Why? Because the value of my mid is 2, right? Now I know the initially count is 2. So in this particular case, here only the condition was satisfied. So I can choose to like not process any further and give my answer that this is possible. But for example, if I want to process even further, what I'll do is I'll just move it one step further. How do I move it? Once I have processed this part, I will check whether this is equals to A or not. If this is equals to A, then I'll add 1 to my answer. But since this is not equal to A, I'll not add anything. And I'll also check the element that has just got out of the range. So this particular element I also have to check. If this element is equals to A, I have to subtract 1 from my count A variable or subtract 1 from my count. So after I do this operation, it will become 1. So it is a kind of a sliding window thing. I have already explained it in yesterday's problem. Yesterday was also a similar problem of sliding window. I'm not sure if it was yesterday or a day before yesterday, but there was a problem on sliding window recently on Geeks for Geeks problem of the day. So it is just a similar example of sliding window where we have to count the number of A's in any given substring of length is equals to mid, right? So what if we already, now what I have the count of A. For example, if I have some count A for any given substring, right? For any given substrings, I have the count A. Now, what I do is I just add something to it. Now, what that can be possible? So, for example, the maximum length of the substring is mid, right? Mid, and I have already count a number of A's. So this particular thing will give me. So this particular thing will give me the number of O's. The number of O's or the number of oranges, right? So what I can do is I can change at maximum m number of oranges into A's. So I'll take the minimum of this particular number, comma m, right? If this is equal to the length of the substring or this is equals to mid, then I can say I can convert all of the oranges into in that particular substring into apples such that the whole string would be containing only apples and its length is equals to mid. So if I have found a string of size mid containing only apples or containing only A's, then my answer at mid is also possible, right? I can always form a substring of size mid by converting the oranges into apples, right? So this is my analogy. As soon as we find, like whenever we find that mid is possible, then we move to the right half of the range. When we find that mid is not possible, we move to the left half of the range, right? So let me just repeat the whole approach once again. So what we are essentially doing is we are using binary search. We are using an invariance technique where we assume that one end of the range is always true and one end of the range is always false, and then we can try to calculate the mid. How do we check whether the answer at mid exists or not? We have this checker function where what we essentially do is we use sliding window to count the number of A's and the number of O's in any particular substring of length mid, right? Then we see how many of those O's can we replace with A's, because we can only replace up to m number of O's, right? So we take this minimum count, and when we find, then we can replace all of them, and the total length and the total number of A's in a substring of size mid is equals to mid itself. That means all of the elements in that particular substring are A's. Then we know that the answer for mid exists, and if the answer for mid exists, we move to the right half of the range and we try to find a bigger answer. If the answer for mid doesn't exist, we move to the left half of the range and try to find a smaller answer. So this would be the solution for today's problem. Now let me show you the code for this problem. So I have initialized my invariance range. So L is always true, that is the low is always true, it is equals to 0, and the high is always false, it is equals to n plus 1. So I just make a simple for loop while L is less than high minus 1. So this is just some standard things that you need to know, that if you are following this particular invariance technique, this is the condition that you have to take. I calculate the mid as low plus high minus low by 2, and I initialize a variable found, which simply denotes that whether all the O's can be converted into A's in that particular substring or not, or whether the number of A's is equals to the size of the substring or not, right? Simply whether I have found an answer for that particular mid or not, right? So I just initialize my count A variable, and I take my first mid number of elements, right? The first mid elements I have to count manually, right? So what I do is I do count A plus is equals to array of I is equals to A. So this is a Boolean condition, right? It will return 0 if it is false, it will return 1 if it is true, right? So I'll be able to count the number of A's. Now the condition that I have just written, if count A plus minimum of mid minus count A comma m is equals to mid, then I found my element, right? If I found my element, I can also like jump to this particular part, but it is not always necessary. You can always process this part also, right? So it will not make any difference. Now after this part has been completed, I start from mid till less than n, and this is a simple for loop. The same thing, I add the current element. If it is equals to A, I add 1, and the element that has to be removed, I check if it is equals to A, I remove 1, right, from the count A variable. Now again, at every step, I check the same condition. If count A is plus minimum of mid minus count A comma m is equals to mid, then I found my answer and I break out of the statement. Like I can break out of this for loop, and at the end, if I have found the answer for that particular value of mid, I move to the right half by making low is equals to mid. Otherwise, I move to the left half by making high is equals to mid. And at the end, I always know that low is always true, so I can safely return low as my answer. So this will be the solution of today's problem of the day, Apple sequences. And I hope you guys were able to understand the solution. If you did, please subscribe to this channel, and you can show your appreciation by clicking on the like button, and also share it with your friends. So till the next video drops, keep coding, stay safe, bye bye.